When our ancestors first looked up into the night sky, they must have wondered at the band of stars and diffuse light crossing the heavens above them. It probably looked like a distant constellation, but we now know that our planet Earth is part of this constellation known as the Milky Way. But it's only through the science of astrometry, the measuring of distances and movements of stars, that we're able to map our place in our galaxy and, by extension, in the universe. The Greek astronomer Hipparchus was the first to map the Milky Way.
Hipparchus, the Greek astronomer that 2000 years ago, he made the first catalogue of stars, which was an important catalogue which was there up to the Middle Age. And he did with the naked eyes, therefore was really impressive. He could go to magnitude 6. And then with the development of a telescope, with Galileo and the first telescope, astronomer could measure more stars and with the higher precision.
While Hipparchus mapped 1,000 objects and charted them on the sky, by the end of the 16th century, another astronomer, Tycho Brahe, created a catalogue of 1,000 stars with a factor of precision 100 times better than what was done by Hipparchus. More recently, in 1967, a Frenchman called Pierre Lacroute revived astrometry with the proposal to place a telescope on a satellite above the Earth's atmosphere. In 1980, realizing the importance to science of this idea, ESA decided to endorse this project, which would eventually be called Hipparchus. I really thought that there was the possibility of doing something in space with astrometry. We worked hard to imagine what methods to use, and then the Space Agency took up the project, and then after the work of many astronomers and engineers, it became the highly successful Hipparchus project. The launch of Hipparchus in 1989 marked a major step forward in astrometry, one that produced results about 10,000 times more accurate than those of Tycho Brahe 400 years before. By placing a telescope in space, ESA was able to measure the position of stars without the distortion of the Earth's atmosphere, which had previously deformed measurements taken from the surface of Earth. 4 years after its launch, Hipparchus exceeded all expectations by producing 1 million bits of information, which, after being received by ground stations in Germany, Australia, and the United States, went into the biggest computation in the history of astronomy to produce the Hipparchus and Tycho catalogues. These catalogues of measurements pinpointed the position of more than 100,000 stars to high precision and more than 1 million stars to lesser precision, and as predicted, became the reference for astronomers for the last 15 years. But it's now time for ESA's new astronomy mission, Gaia, to build on the legacy. By harnessing advances in technology to build the largest CCD optical plane and the most stable casing to date, Gaia will be able to see 10,000 times as many objects as Hipparchus. It will produce the most extensive and accurate catalogue of the objects in our Milky Way, 100 times more accurate and all-encompassing than that produced by Hipparchus. This will allow astronomers to create a new map that will massively improve our understanding of the Milky Way, how it has evolved in the past, and how it will evolve in the future.